Geobyte.
Let us discuss about these kind of properties. See, first of all, tensile stress. What is tensile stress? Suppose I am taking this cylindrical member. Suppose if I am applying a tensile force, I am stretching, I am applying tensile force. What will happen? It will get elongated. The restoring force which is developed because of the application of force to the unit area is called as tensile stress. Here we are considering the tensile force. Here we are considering the tensile force. Suppose if I am applying the compressive force, I am compressing the cylindrical object, what will happen? The restoring force which is developed because of the application of compressing force to the unit area. So here we are considering the compressive force. Just like we have discussed in previous case into cylinders. Next one is tangential stress. I am taking same. Let us consider one cylindrical object. So here we need to apply an equal and opposite force F. What will happen because of the application of force? Here, whatever the cylinder, this is the original cylinder. Here we are applying two forces which are equal and opposite in direction. What will happen? This is the line of action of the cylinder. Here, because of the application of force, it will get deformed. So here, original position was changed. So there is some change in the displacement. This displacement is called as relative displacement, which is denoted with delta x. Original length was given as L. So there is some angle of deformation. It should be taken as theta. Theta is called as angle of deformation, and there is a change in the displacement. That displacement is called as relative displacement. So because of this application of force, it will get displaced. That relative displacement is denoted by delta x, and that angle of deformation is given as theta. Here, what is strain? Change in length by original length, delta x by L. Here we are applying the force tangential to the cylinder. So the corresponding stress is called as tangential stress or shear stress. Next one, volumetric strain. What is volumetric strain? Volumetric strain is defined as the change in volume to the original volume. It is the ratio of change in volume to original volume. So all these properties were given by Robert Hooke, and he developed one law which is called as basically Hooke's law. In that he was discussed about the relationship between stress and strain, how these parameters will vary. So here the thing is mechanical properties of solids. So when the solid object changes its proportions, like changes its dimensions, changes its properties. So because of the application of load only, they will changes its properties. So here we have seen stresses, strains, elasticity, plasticity, all these parameters. So these are all comes under properties of solids. Hooke's law. What is Hooke's law? Robert Hooke developed one law, relation between stress and strain. It shows the relation between stress and strain, and This law shows that within the elastic limit, stress and strain are directly proportional to each other. Within the elastic limit, stress directly proportional to strain. What will happen if stress is directly proportional to strain? Suppose I am applying 10 kilonewtons load. I am getting 1 mm deflection. Change in 1 mm deformation. After that, I am applying 20. Here I am getting 2 mm. Here the incremental deformation and incremental load, they should be coincide, and here these are proportional. Here we are applying the load gradually and we are getting this simultaneous deformation. So he proposed one constant here. He replaced proportional constant here. Stress equal to K into strain, where K equal to stress by strain. What is K? Constant of proportionality. It is the ratio of stress to strain. It is also called as Young's modulus or modulus of elasticity. So where K is the ratio of stress to strain, and it is also called as Young's modulus or modulus of elasticity. In this class, we will see in the stress-strain relationship. There is one curve which is called as stress-strain curve, which is developed by Robert Hooke. Here, we will see the relation between how stress and strain will vary. Let me draw. Suppose I am taking one solid object, cylindrical object. I am applying some load. I am applying tensile load. What will happen? It will get elongated. So there is some change in the member, that is called as deformation because of the application of the force. See here I have drawn stress-strain curve. See here, I have drawn stress-strain curve. It was developed by Robert Hooke. In most of the, generally, we need to take stress in the x-axis, stress in the y-axis. Let me write the axis. Here, we need to take stress in the y-axis and strain in the x-axis. Why we are making the relationship between stress and strain? Generally, while testing the objects, we are applying any force. There is some changes because of that application of forces. Generally, we are getting some kind of deformation, changes in the length or changes in the shape of that object. Suppose we are taking 1 mild steel. See, let us consider this as 1 mild steel bar. In mild steel, I am doing tensile test in universal testing machine. So I am applying the tensile force. What will happen? It will elongate. Suppose I am applying 10 kilonewtons. It will get some kind of deformation, maybe 0.1. Suppose if I am applying 20 kilonewtons load, it will get deformed to 0.2 mm deformation. So depends upon the application of load, the material property is changing. It is going to be deformed because of the application of force. See here, I am applying the load. So in addition to that, I am getting the strain because of there is some relation between stress and strain. Stress means force by area. Application of force, restoring force to the unit area. Here straining means change in length to original length. So there is some kind of relation between stress and strain. So first I am applying 10 kilonewtons load. I am getting 0.1 mm deformation. Here we are getting some relation between stress as well as strain. Similarly, I am increasing stress as well as I am getting some kind of strain. So this is keep on going until this point A. What will happen? Until this portion, Hooke's law is obeyed. What is Hooke's law? Stress is always directly proportional to strain. Whatever the stress I am giving, I am getting the corresponding strain. So I am applying some gradually load. So I am getting some uniform strain. I am applying some load which is gradually on the member. So I am getting some kind of deformation. So there is some relation between stress and strain until from O to A. Here Hooke's law is obeyed. So here until this portion Hooke's law is obeyed. Whatever the application of force I applied previously on this member, I am removing suddenly. So it comes back to its original position. So that is elasticity. Suddenly, because of the application of force, it keeps on increasing. Here I am applying, so because of the application of force, I am getting stress. Similarly, strains. So for corresponding stress, I am getting the strain here. So it keeps on increasing. So this region from A to B, this portion. So this region is called as elastic limit. This region is called as elastic limit, and this point is called as yield point. The corresponding strength at this point is called as yield strength. Next, same, I am increasing the load. Suppose until B, I am applied only 100 kilonewtons. After that, I am increasing 110, 120 like that. Same, the strain was increasing. See here, because of the small stress, I am getting strain. So this is yielding point. This point is called as upper yield point. This point is called as lower yield point. After that, see here, you can observe suddenly there is some change in the deformation until here. If I am applying some force, I am removing that force at some point until C, it will come back to its original position. But you can observe here, if there is some change suddenly in the deformation, means strain. So this deformation region is called as plastic deformation. Plastic deformation. So here I am applying the load and it cannot go back to its original shape. So here deformation is still going on because of the application of load. So it comes under plasticity. The material gets the plastic deformation. So next point, D. D is called as ultimate point. So here we will get the ultimate strength. Ultimate means maximum stress. Maximum strength. Whatever the material we are taken for test and we are applying the load, here it will, until this point, it will bear. Suppose I am taking this model, still I am applying the load until this is the maximum load it can bear. So until the D, it can elongate. So here until this point we are getting deformation. After that, suddenly it falls down. Suddenly it falls down. What will happen here? This is fracture point. This is fracture point. Here, even though here we are not considering any stresses because maximum strength was reached, but after the removal of load also here we are getting small deformations. So this point at the this is called as fracture point. See here, if the difference between point D and E, if it is very small, the material is called as brittle material. The best example for brittle material is concrete. Concrete is having brittle nature. Suppose if the material is having large distance like this material is called as ductile material. Just like mild steel. Example is mild steel. See, we have seen the relationship between stress as well as strain. Suppose we are testing any member, we are getting the corresponding stresses and strains. So first, until O to A, it obeys the Hooke's law. Hooke's law means stress is directly proportional to strain. After that, this region is called as elastic region, elastic limit. So this point B is called as yield point. Here we are having 2 points B and C. B is called as upper yield point, C is called as lower yield point. Until this point, it will come back to its, suppose if I am removing the load, it will come back to its original position. After that, it will gains the plasticity property because of the gradual application of load. So this region is called as plastic deformation. So we will reach the ultimate strength, maximum strength. So after that, suddenly it fell down. So the last final point is fracture point. Because of the application of load, suddenly at one point it failed. It will get fractured. So this point is called as fracture point. If the distance between these two is less, we will call that material as brittle, and the best example is concrete. If the distance is more, we will call the material as ductile material. The best example for ductile material is mild steel.
Geobite.